Next, we are going to discuss about the FET. So in that we have used the GAS and ion sensing material. How it will be working, we can see one by one. So field effect transistor, where we use the field effect, how we can call as a field vector. Based on that advancement of the field effect transistor, we have gas and ion sensing material we are using to explore the miniaturized sensors we are transforming from various industries. So we can use the various industries in the main applications, like it's a safer and smarter to the world. That's why we are moving to the field effect transistor FET. So next, why we need for FET? Here we have the sensing material we are using rotatory. So based on the rotatory, we will detect and how much time it will rotate, we can calculate. And mainly, why we use for FET sensor in the sense it's miniaturization and the efficiency. Miniaturization in the sense the material of the devices and the size of the devices is miniaturization, and the size is very small, tiny material. So and efficiency also good. That's why we are using the FET. So ultra low power consumption here. It's the main advantage again. So that it perfect suitable for IoT and other portable devices. That's the main advantage. We have chosen the FET sensor. And high sensitivity and reliability. Another advantage is main thing, that the CMOS complementary metal oxide semiconductor we are using. It is very ensure that the seamless integration with the modern electronics is a very important thing. The reliability also is very good. And broad applications where spanning of environmental monitoring, medical diagnosis, and industrial safety purpose and all very useful for the FET sensor. That's why three important parameters are used. We go for the FET sensors. And why we use core and how the FET sensors can in gallium and ions, when sense it will conduct the conductance modulation of the electrical field, and also the current through the material through the FET in the semiconductor channel. FET is executively sensitive for the gate voltage. Based on the gate, it will producing the external or other voltages. And also we target the gallium arsenide molecules or ions instead of ions. It will be very useful. And the sensor surfaces, and also having the main function of the change of the surface, it will be chargeable, and the working function of the devices is suitable for, and it will directly translate to the FET devices exactly. And what is the nanoparticle functions in the FET? Mainly the FET is integration, that is a palladium. That's a palladium we can use for the tunneling purpose, and it more sensitivity comparably the other material what we used here. The hydrogen detection will be also good. So and also here we have the 1 to 1000 ppm values and the room temperature. So automatically that low parts per billion, it will be varying the range from 1 to thousands. And ultra low power consumption here, that's the main advantages. So mainly we have the 300 nanometer level, it will be work. So this is the main functions of the hydrogenic sensors we are using the FET. And advantages in the material and design search for the enhancement performance mainly. It pros the interim gates is the main silicon of the FET enabled to the ppm gas. So it will direct and pushing the limits of the sensitivity is minute. And the suspended and the cylindric category metal FET gate are we are using here. It will be improve the gas accessibility and accelerate the response level of the speed, and also critical and real monitoring system we have used for the metal. That's a gate fed metal. And integrated micro heaters rarely used to allow the precise control of the sensing area environment with the internal power consumption we are using. And also the optimization sensors material performance we are using, main advantages here. And we have some challenges in the FET. That's the balancing performance and the scalable production and the seamless integration. These three are the very important parameter here. With achieving the optimal potential sensing and also along the long-term scalability and the dynamic environmental conditions, and the remains are the big key challenges for the widespread of adaptation. And also simplifying the fabrication process in the crucial cost effective and also high manufacturing of the FET sensors. That is the main scalable productions of the gate and fed, and seamless integrations is mainly used for the advantages and the process where the wireless communication in the while development in the smart integrated circuit, that is the sensing of interconnected platform circuits. And also, FED is the sensor to empowering the signal value, that is a continued innovation, seamless integration, and inputs presence are the main important parameter for the sensors to empowering the safer and the smart world. It is suitable for the other comparable devices. Thank you.